Hello, everyone. My name is Jenna Jaden. I work for the U.S. Department of Agriculture, and I'd like to welcome you this afternoon to the U.S. Center. If you haven't been here before, the U.S. Center is a public diplomacy effort put on by the State Department, where we like to showcase all of the U.S. efforts at understanding and combating climate change, both abroad and domestically. Our presentation this afternoon is entitled Taking the Pulse of the Planet, the State of the Climate. And our two speakers are Mike Brewer and Derek Arndt. Mike Brewer is a climatologist at the U.S. National Oceanic and Atmospheric Administration, or NOAA, in the National Climatic Data Center. He manages the U.S. Drought Portal, the North American Drought Monitoring Portal, and the Global Drought Information System, and authors Drought Monitor Assessments. He is an expert reviewer for the Intergovernmental Panel on Climate Change and a contributing author to the U.S. National Climate Assessment. Derek Arndt is the chief of the Climate Monitoring Branch at NOAA's Climatic Data Center. Derek, or Deke Arndt, joined NCDC in March 2009 as the chief of the Climate Monitoring Branch, which is responsible for monitoring and assessing the state of the Earth's climate system. As an applied climatologist, his work encompasses research and service aspects that are centered in utilization, helping people make better climate and weather-sensitive decisions. Just to let you know, we're Skyping in our speakers. You're going to see both of them up here. And we're also going to be live streaming this via Ustream, so we're going to have an audience around the world. And with that, our speakers can go ahead.
Hi there, and hello from Asheville, North Carolina. It's a privilege for Mike and I to join you at least remotely today, and I hope you've had a great day. We're just beginning the day here in the U.S. I know you've already had a very busy day, so we'll start talking about the State of the Climate report. We're also representing Dr. Jessica Blunden, who has actually been the lead editor for the State of the Climate report for the beginning her third year now. So we've worked with her in various capacities to produce these reports. So the state of the next slide, please. Thank you. So the annual State of the Climate report it's an annual miniature assessment. It basically reviews the state of the climate system around the world, and the climate system, as you know, is very complex, and it's not just about global temperature, but it's also tracking many of the different indicators, or what we call essential climate variables around the world. So the most recent version of the report actually tracked 43 of these essential climate variables, or climate indicators, and what is their behavior both in the year of 2011, but also in the longer term for as many years as we have on record for each one of those variables. This happens to be the 22nd annual edition in the series, and we had a record number of authors, 378 authors contributing to the report from 48 countries around the world. So it's truly an international effort because it is an international global scale in scope. It's only natural that we have international participation, and that has grown dramatically in the last 5 or 6 years of the State of the Climate report, and we think it's really helped improve both the amount of content, the quality, and the number of perspectives on the climate system. All right, next slide, please. So in 2011, some of the things that were a big deal that we tracked during these 378 authors tracked during the year were the big picture climate. So this slide represents the different chapters in the report, and it's laid out kind of how you would think a pretty logical way to cut up the climate system. Again, it's very complex. It's hard to assess the entire thing at once. So what we try to do is divide it up into different subcomponents and assess how the behavior of each one of those subcomponents is. So there are large-scale global indicators where we take global or near global averages for various weather and atmospheric variables. We have some listed here: temperature, water vapor, precipitation, and so on. Then also a chapter with its own editors and authors that surveys the oceans. How is the state of the sea in as much as surface temperature, deeper temperature, salinity or the amount of saltiness in the ocean in different places, sea level, and so on, the different currents. Then we have a section devoted to the tropics, which covers some of the tropical oscillations like El Nino, La Nina, and the different tropical cyclones, whether they're called typhoons or cyclones or hurricanes around the world. A big section dedicated to how are the world's tropical cyclones behaving. Then, of course, we have two chapters, one dealing with the Arctic, which is changing very, very rapidly. In fact, it's probably one of the most striking chapter, or it is probably the most striking chapter from this last report. The Arctic continues to change in ways that outpace even the rest of the world. We'll go into that in a little bit. The Antarctic deals with a very important continent, a continent that has a global reach in terms of the way it is connected to the ocean and atmospheric currents. So a lot of times we forget about the Antarctic when we're thinking about global climate, but it's an important place. And then regional climates, which tell the story of what happened in different parts of the world, almost on a country-by-country basis. What was important that occurred in each of the participating countries during 2011? What are the trends in those countries, and how did 2011 fit into the big picture? So next slide, please. So one of the global chapter, it deals a lot with indicators, and these are typically variables that describe some component of the atmosphere, such as humidity or temperature or sea surface temperature. And these indicators often come from different data sets. And what you can see on the screen here is a continuation of long-term trends in each of these 11 indicators. There's 10 on the screen right now. So each one of these, you can see there are several data sets. Each of the lines represents an independent data set or an independent analysis dealing with different data sets. And you can see with the black arrows pointing up, those are elements that we would expect to increase in a warming world. All else being equal, we would expect temperatures to go up, of course, as the globe warms. We would expect the humidity in the lower atmosphere to go up as the globe warms. We would expect the sea level to go up as the globe warms. And in the long term, we are seeing this with some year-to-year variations, but the long-term signal is up in recent decades. And where you see basically dealing with frozen stuff, glaciers, snow cover, and sea ice, in a warming world, you would expect those to decrease. And on the average around the globe, this isn't true for every place in the world, but when you average it around the globe, these indicators are going down. And so this is an effort that we started with the 2009 report, and we have continued on through this current report. Next slide, please. So we added a couple in 2011. One of our drivers, one of our goals with the State of the Climate report is to add more and more of these essential climate variables, these new indicators that help describe important subcomponents of the climate system that we haven't previously tracked, at least in this report. So this last report added both ocean acidity, what is the pH or the acidity of the ocean, and that is acidity is increasing in the oceans, and we added albedo, which is the reflectant, the reflectivity of the land surface anyway of the globe, and that is decreasing. Again, these would be expected in a warming world. All right, next slide. So the various long-term trends continue. 2011 surpassed 390 parts per million of carbon dioxide for the first time. So the carbon dioxide trend continues to increase. This is one of the most reliable kind of year-by-year increasing components in the climate system that we see. So CO2 concentrations, as expected, continue to rise. Global temperature was in 2011 off from its peak in many data sets that occurred in 2010, but the long-term trend again is up. The decrease in global temperature that we saw in 2011 was probably largely related to persistent La Nina, which tends to be represented by a large cooler than normal patch in the Pacific Ocean, and this can have a lasting effect throughout the year, and it indeed did in 2010, or 2011, which pulled it down from the previous year, and we'll probably see in 2012 the La Niña weakened a little bit, or wasn't as persistent throughout the year, and in fact went away early in the year, but it was there long enough to keep 2012 also below the temperatures that we saw in 2010. Again, the long-term trend is up, but any given year from year to year, you're going to have variability, and we see that throughout the system and many of the variables that we observe. The ocean heat content did set a record in 2011. It was a much shorter time period, so this is a data set that's really only about 20 years old, but in 2011, the upper ocean heat content, and that is a way to measure the amount of energy in calories or joules in the upper 700 meters of the ocean, that was the highest according to several data sets that we've seen in that short period of record. Next slide. A few other points. 2011, like almost all of the recent years, was among the top 15 warmest years on record. It was actually, much cooler than the warmest year, which was 2010. But even with the 2011 being off the peak, the warming in the last 3 decades, is triple the rate that we saw over the entire period of record. So if you look since 1880, if you look at the 130 or so years on record, we see an increase of about 0.11 degrees Fahrenheit per decade, or about 1 degree per century, is the rate of cooling over the long term, the entire period of record. But if you look at just the last 3 decades, it's triple that. It's 0.31 degrees Fahrenheit per decade, or about 3 degrees per century. So the warming, even with 2011 considered in there, again in recent decades, is larger than the long-term trend. All right, next slide, please. Precipitation, 2011, much like the year before it, was much wetter than average over land. In 2011, it was also relatively dry over the ocean. And we saw in the salinity, we mentioned the saltiness of the ocean, a really interesting signal. The areas in the oceans that are already salty were even saltier in 2011, and the areas of the ocean that were relatively fresh or less salty in the oceans were even fresher than normal in 2011. And what this implies is an increase in the hydrologic cycle. The salty areas are salty to begin with because evaporation dominates precipitation. More water is evaporated over those areas than falls, and the fresh areas are dominated by precipitation. So more water, fresh water, falls onto the ocean than evaporates. And when you see these characteristics become a little more extreme or a little more pronounced, that implies, as would be expected, an increase in the hydrologic cycle, at least over the oceans and at least during 2011. And it's pretty consistent with trends that we've seen in recent years. So again, global temperature is probably the one statistic that gets boiled down into a single number and widely broadcast, but it's these other variables and other phenomena and other important elements of the climate system are also very important, and in many ways have a more immediate impact on both the people and the ecosystems in the areas that they're affecting. And this salinity signal shows that precipitation patterns, at least for the last couple of years, seem to have intensified, where the wet areas are getting wetter and the dry areas are getting drier. And it has been a couple years now of very notable precipitation extremes. We'll talk about the drought here in North America in just a second, but that was one interesting finding from the 2011 report. All right, next slide, please. So for water vapor, an important component in the system, it is expected that as the world continues to warm, that the atmosphere will be able to basically hold or convey more water vapor. A warmer atmosphere can hold more water vapor. And so far, near surface humidity variables show a slight increase with a lot of year-to-year variability over time. So for as long as we've kept global scale records of this, we do see an increase in what we call specific humidity, or an actual measure of the total amount of water vapor in the lower atmosphere over both land and ocean, although those increases, when you compare them to the year-to-year variability, do not overwhelm the year-to-year signals. So there is a slight increase. 2010 was a very humid year, globally averaged around the globe. 2011, not so much. So we do see increases as we would expect in a warming world. Those increases, as of yet, are not as dramatic as some of the other indicators that we've seen. All right, next slide, please. One of the important features that we mentioned earlier was the pattern La Niña. And what we see here are two images from around the world that are consistent with La Niña. So La Niña dominated a lot of the global weather and climate patterns in 2011. And when we have a La Niña, which is associated with cooler than average temperatures in the equatorial Pacific Ocean, and some atmospheric patterns that support these, namely a strengthening of the trade winds over that region. This pattern is actually connected to much of the rest of the world's weather and climate outcomes, especially on a seasonal basis. And La Niña is often associated with flooding on the Australian continent. We saw that in a huge way in 2011. So the upper right photograph shows the consequences of just some of the flooding that was observed in Queensland, Australia, which was very wet in 2011, very consistent with what you would expect during a La Niña. And we also saw drought in East Africa persist in much of 2011, although it did improve somewhat towards the end of the year. But these are both consistent with what we would expect with La Niña. And we saw a pretty marked event. This will go down as one of the more prominent La Niña episodes in recent decades. All right, next slide, please. In the tropical cyclones, so this is a summary of the tropical cyclone activity throughout the world. There are many basins, ocean basins, in which tropical cyclones can occur, and we have been in recent years in a higher activity era, is what we call it, in tropical cyclones. What we did see in 2011, and also in recent years, 2009 and 2010, were a number of the number of total tropical cyclones was down somewhat versus recent years, but we did see an above average of really intense storms in 2011. In particular, the North Atlantic basin, the basin that affects much of North America and Central America ultimately, has been very active, while the rest of the global ocean basins have seen a smaller number of tropical cyclones. But again, the number of intense tropical cyclones was above average during 2011. We saw a number of particularly Pacific storms that were very intense, very early in the year as well. So next slide, please. Sea ice continues to decline. I think we've seen a lot of attention paid to sea ice, especially this year in 2012. So as of 2011, the content that was published in this report, 2011 was the fifth of 5 straight years with much below average Arctic sea ice in September. And in the Arctic, we're seeing sea ice retreat, especially in the summer months in the melting season, dramatically. The overall maximum that we see in the month of March, so sea ice will in the Arctic will grow up through the month of March and reach a maximum usually sometime in the month of March, and then retreat through the warmer months until September to its minimum footprint of the year. And what we're seeing is that the starting point, when it reaches its maximum in March, is getting slightly smaller on a year-by-year basis. But the September retreat is actually where we're seeing a great deal of change in the Arctic. And 2011, like the 4 years before it, was in kind of new territory. And again, of course, as we all know, 2012 set a new Arctic sea ice minimum in September. The long-term trend is for smaller Arctic sea ice minimum in September. And what this means is when the ice recovers in March, we're seeing less and less multi-year ice. So much of the ice that we see in the month of March is single-year ice or first-year ice, and this young ice will actually melt a lot more rapidly, and so we're kind of in this cycle of record and near record September sea ice minimum in the Arctic. All right, next slide, please. So the Arctic amplification is a term that's common with many Arctic researchers and people that study global climate. And what it refers to is the changes in the Arctic, not just in temperature, but in a lot of the associated variables and phenomena, seems to be or is occurring more rapidly than in the rest of the globe. This was pretty much expected by most climate model projections that the Arctic, because of the many positive feedback mechanisms in the Arctic, the changes would be faster than the rest of the planet. That's indeed what we're seeing. And it's not just temperature and it's not just sea ice, but it's a lot of the related variables. We're seeing places around the Arctic rim have more and more warm days than they have seen in their recent histories. Barrow, Alaska, for example, had 86 consecutive days with temperatures at or above freezing. That was a record for that location. It goes back about 100 years. We're also seeing this warmth penetrate into the ground. So land areas in and around the Arctic that up until recent years were permanently frozen. We're seeing a thawing of this permafrost and a warming of the permafrost that is not yet thawing in most places around the Arctic. And this would be, northern North America, the Arctic areas of Eurasia as well. In most locations, the permafrost is melting or is thawing, in some places, and it's pretty much warming throughout the profile as well. So those are two trends that we saw that were continued in 2011. All right, next slide, please. Greenland was probably the most striking anecdote in the year of 2011, and probably as editors, I know Jessica and I would agree that the section on the Arctic and especially Greenland was kind of the most arresting of the changes that we're seeing, and the mass loss, the amount of ice that was lost from Greenland during 2011 was among the highest on record, a record that dates, depending on how you measure it, to the late 70s or to the late 1950s. So Greenland continues to lose ice through melting and a little bit through evaporation as well. And we saw that continue in 2011. Next slide, please. The Antarctic, in the long term, the temperature trend is generally flat over much of the Antarctic. There is a slight warming signal in some stations, but it is overwhelmed by the natural year-to-year variability. So the Antarctic, kind of in many ways, is a completely different animal than the Arctic. And the rapid changes that we're seeing in the Arctic, we're not seeing those changes, at least not in the variables that we're comparing between the Antarctic and the Arctic. So the Antarctic saw a great deal of warming up until or through the later part of the 20th century, but in the recent 10 or 11 years since, it has flattened out, and we do see a lot of year-to-year variability in the signal. All right, next slide. And then jumping back to the Arctic, one of the consequences of this rapid change in the Arctic, there's a freshening of the sea surface, but there's also a change in the vegetation. We're really seeing a greening up in the land areas around the Arctic. It's been referred to as the shrubification of the Arctic. So we're seeing plant life emerge and actually become larger in many areas of the Arctic. It's a topic that's under a great deal of study. So as conditions continue to change in the Arctic to support larger and larger plant life, we are seeing in many areas larger and larger plant life emerging in the Arctic. All right, next slide, please. Finally, focusing down on some regional climates. In North America, 2011 itself was quite dry. It was the beginning of what has become a multi-year drought, or at least a 2-year drought in much of North America, which the last year and a half or so, the dryness actually is opposite of the trend. The trend in the United States, and especially in Canada, is for wetter and wetter years. So this drought that we're experiencing in North America now, in many ways, stands in the face of recent trends, or opposes the recent trends, and it makes it that much more unusual. I know Mike's going to speak a little bit about the drought and its impacts in North America. But this was the first year, especially in Canada, in many years, to see much below normal precipitation. Most of North America, on average, again, this is averaged across the continent, has enjoyed wetter than average years until 2011, and that 2012 is also going to be quite a dry year for these countries. All right, next slide, please. So in the U.S., what we saw in 2011 was a warm year, and it continued a recent trend of warmer than normal years. We saw many states in our eastern and northeastern sections of the U.S. Much warmer than normal, or what we would call much above normal, in the top 10% of their history, of their observed history. And we saw the southern part of the United States also quite warm. The southern U.S. had a very warm and a very dry summer in 2011, and we saw the beginnings of the drought that in 2012 expanded. In 2011, that drought basically had its epicenter in the south central United States. It became very intense by the summer months, summer 2011 months, and since then, as Mike will talk about, that drought has expanded into much of our central and northern plains and into our Rocky Mountain and western states as well. We saw dry conditions in the southeast. The states of Georgia and South Carolina were also quite dry, and they have experienced drought conditions over much of 2012 as well. So again, 2011 in general was warm and dry in places. We had amazing flooding, producing precipitation during the spring in our Ohio Valley and northeastern states. So 2011 was marked by extremes in precip. We saw the spring flooding. We saw the Ohio and Mississippi rivers during 2011 reach record stages in many places. At the very same time, just a few hundred miles away, or about 1,000 kilometers away in the south central U.S., we were seeing record or near record dryness in many locations. So we saw a really persistent pattern that caused a lot of stress on the system in 2011. All right, thank you. Next slide. Around the world, there was a bunch of extreme events, as there is in any year. You will see extreme events. Some of the extreme events were consistent with what we would expect during a La Nina episode. The drought in the southern United States and northern Mexico during 2011, not necessarily caused by La Nina, but it was definitely consistent with expectations during a La Nina. The North Atlantic, the hurricane season that we saw experienced in North America and Central America, that was above average again in 2011. That's also quite consistent with what you would expect with the La Nina. The North Pacific, Eastern North Pacific anyway, produced fewer tropical cyclones than average, also consistent with what you would expect during La Nina. And we saw flooding in Brazil and in Southeast Asia that was consistent with what you would expect with La Nina as well. We also saw a lot of extreme events that are not necessarily connected to La Nina and are probably more associated with the kind of random nature of weather that you would expect. We saw a record number of tornadoes. Several outbreaks were quite large in the United States. We had a very violent spring in 2011. We saw some cold and hot snaps in Eurasia that were historic, and we saw a very, very powerful cyclone strike northern Australia also in 2011. Those were some of the big events that caused hardship, all of them, around the world. All right, next slide, please. Finally, the Texas heat wave, one of the things that a companion to the State of the Climate was an article dealing with attribution and how likely certain events are in a changing global climate system. So the heat that was experienced concurrent with the drought in the southern plains, it became known here in the U.S. as the Texas drought or the Texas heat wave. Even though it was larger than the state of Texas, it was much of the south central United States. One of the attribution studies in a companion document to the State of the Climate found that a heat wave such as we saw in 2011 is about 20 times more likely during La Nina years as it was in the 1960s. I'd point out kind of conservatively that this was just one of many attribution studies that was conducted, but those results, again, are consistent with what we would expect in a warming world, is that behavior that used to be on the very extreme end of a probability distribution, or the chances of such an extreme used to be extremely low. Well, now according to some attribution studies, the chances of such events have gone from extremely low to low, and that's an increase. And what it means, we think, is that more people will be experiencing certain types of extreme events more often than their grandparents did. All right, next slide. A similar study for a cold outbreak in 2010 compared to a warm outbreak 1 year later showed basically the same thing, that we're going to be experiencing the warm end of the spectrum, or what was the warm end of the spectrum, a little more often as the world continues to warm. All right, next slide, please. So finally, just in summary, what we found with the State of the Climate report, again, we're very thankful for the participation from all of our authors around the world. We could not produce a comprehensive document without partnership from dedicated people in academic institutions and meteorological services around the world, and we're very appreciative of their participation. What we saw in 2010 is 2011, I'm sorry, the long term, the climate indicators that we would expect to increase are increasing, and those that we expect to decrease are decreasing. 2011 was less extreme than 2010 in many regards, but it still contributed to the trends that we see in these variables. And then finally, La Nina and the Arctic were probably the two biggest events of 2011 as well. All right, next slide, please. So just to speak very quickly about the year that we are having so far, we are seeing continued rapid changes in Greenland and the Arctic. We did have a rare melt episode where the surface ice of Greenland during August, we saw a couple days where there was essentially a small amount of meltwater across much of Greenland that was due to a large heat wave that it was established over the ocean or over the island, and it was not necessarily associated with long-term warming, but it was a very rare event. We've seen quite a few flooding episodes around the world. We've seen a drought in the U.S. and North America that will go down as one of the bigger drought episodes we've experienced in the last century or so. And we saw a record cold outbreak in Europe that we saw cold and snow penetrate deep into southern Europe, providing some really rare snowfalls in that part of the world. And then we obviously have just experienced here in the U.S. A system with tropical origins named Sandy that delivered a large storm surge and much damage to much of the northern Atlantic coast here in the U.S. And thankfully, we've also seen some relief in the drought conditions continuing into 2012 in much of East Africa as well. Next slide, please. We've had a fairly warm year to date. What this graphic shows is how this year's temperatures through October have compared to the 30-year period of 1981 to 2010, where you see pink and red colors. Those are areas that have been warmer than normal, and where you see blue, those have been cooler than normal. 2012 likely won't be the warmest or threaten the record for the warmest year on record. It looks a lot like any of the recent warm years looks. There's a lot of pink and red on the map, and there's a little blue on the map as well. So again, when we talk about global temperature, we're averaging areas that are very warm with a few areas that are cold as well. So the warmth that we've seen here in North America, we haven't, we've seen areas of colder than normal conditions around the world as well. Again, any warm year is going to have pockets of cold as well. All right, next slide, please. This is the same data, but transformed a little bit to look not at how warm the year has been compared to an average, but this is how warm the year has been compared to a place's own history. So everywhere on this map that you see the darkest red, those are areas of the world that on average are having their warmest year to date on record so far. The medium shade of red shows areas that are much warmer than average or in their top 10% locally. And then warmer than average, the lightest pink, that's in their top third or 1/3 of their own history. The white colors show areas that are in the middle third of their history. And then the blue colors show areas that are having either a cooler than average, which is the coolest third of their history, or much cooler than average. There are a few pixels with much cooler than average values, and those are having a bottom 10% year as far as temperature goes. All right, next slide, please. And next slide, please. Finally, in the U.S., and Mike will talk about the drought consequences, we will almost certainly have the warmest year on record in the United States, or for the contiguous United States, or what some people refer to as the lower 48. We had a very warm March, we had a very warm summer, and those have really pushed 2012 out ahead of the pack. So what this graphic shows is the year-to-date average temperature for each of the 118 years on record, with the 2012 being the 118th year of the series. So in the values in January show the January average. The values in February show the January-February average. The values in March show the average of the first 3 months. These are all compared to the 20th century average for those months. And you can see that in March, 2012 really shot out really far away from the distribution, and has maintained the rest of the field kind of at arm's length. We will, again, almost certainly have our warmest year on record here in the contiguous U.S., even as the globe has a year that likely won't threaten records. So in any warm year, you're going to see parts of the world have record warmth, and it just so happens it was kind of North America's turn in 2012. Really historic as far as temperatures go. All right, next slide, please. This is basically a projection using history as a guide and not really considering the many great forecasts and outlooks that come out of various prediction centers. Just using history as a guide, it would take basically at the end of October, we would have to have a bottom 10% November and December to not break the record. And basically the way the temperatures have worked out so far in November, we have an even smaller chance of not having the warmest year on record because November is actually going to come in fairly warm here in the US. All right, next slide, please. This slide just shows that we've had the tops, that if you take the average temperature in consecutive 12 months period and compare those to all of the consecutive 12-month periods on record, we've basically had the 7 warmest 12-month stretches on our record have ended all in 2012. So the red bars on this graph, these represent the warmest 12-month periods that we've seen in the contiguous US, and every bar that's red is a 12-month period that has ended in 2012. Just another way of looking at the same situation. It's been warm here in the United States. All right, next slide, please. And then finally for me, we've had quite a few record individual days. So any warm year is going to come with some very warm stretches within it. And what we've seen setting some very warm records, in some cases smashing records, it's just a sample from September of stations that broke previous records by as much as 10 or 13 degrees Fahrenheit, which is really, really a large amount. So parts of our country in different times of the year, it's been different parts of the US, but we've seen some really breathtaking new records set as far as warmth go. And with that, I believe I'm going to turn it over to Mike. He's going to expand on the drought situation in North America.
Yeah, so Deke mentioned the drought, and I'm just going to, or mention the temperature, and I'm just going to pick up on one of the impacts of temperature being the drought. He mentioned that in 2012, we had basically the continuation of the drought through 2011, but it expanded out of the southern plains and moved into the Rockies and up into our agricultural producing areas, Midwest and the high plains. And this is a comparison of the current, of the drought of our summertime versus the 3 most severe droughts the U.S. has experienced in history, in our instrumental history, being the 30s, the 50s, and the late 80s. And as you can see, July 2012 stands in contention as one of the worst droughts in history. So what we wanted to look at, next slide, please. And are we on 32, just to make sure? Let's go to 32. We decided to look at, we knew that there was the La Niña in 2011 and early 2012, which would contribute to the drought through the southern plains, but it wouldn't explain the drought necessarily through the Ohio Valley and up into the plains. So what we looked at was basically the impact of temperature. So the Palmer Drought Severity Index, which you saw in the last slide, as well as it's used in this slide, is basically using temperature and precipitation and looking at soil moisture and determining some drought stressors based on those indicators. So if you take the extreme temperatures from 2012 out of the equation and you just looked at what happened with precipitation, what we found was that the drought would not have been nearly as severe. If we ran a Palmer Drought Index with the actual precipitation, but we used a normal temperature, a 30-year normal, instead of this year's temperature, what we see here is the difference between the actual temperature-related drought and that surrogate amount. And what you see was basically that over almost all of the United States, the extremely high temperatures, the record-setting temperatures of 2012 really contributed to the drought. They did that in 1934 as well, but they did not so much in the 1950s or the late 1980s, which just goes to show you that every drought has its own flavor. They're all unique. It's what makes it so hard to predict. But since it's one of the most devastating and costly natural disasters around the world, it's good to get a handle on this. And finally, this is the impact that we've been experiencing on that drought so far. As of November, this is the area in the U.S. of winter wheat that's experiencing drought. And as of the middle of November, 63% of the country's wheat-producing areas were in drought. And this is exacerbated by the drought that also showed up in Europe and through Asia and in some of the other grain-producing areas. And as you all know, this is going to have a devastating effect on food prices in the coming year. Loss of corn over the summer, some likely loss of wheat due to the drought, even ongoing now. And we haven't had a chance to look at this over the rest of the world, but we expect to see something similar. And with that, I believe that we're finished and happy to take questions.
Okay, great. Thank you, Mike and Deke. I'm going to take question from the audience first, and then we'll switch over and see if there's anything on Ustream. We've got about 15 minutes for questions. So does anyone have one?
Good afternoon. I'm Rosalina de Guzman from the Philippine Met Service. During the last decade, we have seen more El Nino events. So it seems that the cycle is broken. Is this what we're going to see in a warming world?
So that's one of the great research questions that's actively being pursued, and basically the results so far in that research. Some research results point to a stronger preference for El Nino dominated periods in a warming world, but I would say that these results aren't considered kind of final or conclusive. How the big picture warming of the world translates down into these more regional and more seasonal phenomena is an area of research that's going to keep a lot of people busy for a long time, and that is where the next really big gains in our understanding are going to play out. So there are some of the studies that point towards a stronger preference of El Nino dominated periods, but the results are far from conclusive and far from unanimous so far.
Okay. We have another question.
You spent time talking about the Arctic sea ice, and if you look back at the 2007 report, I believe it was, and the projections for Arctic sea ice as to the rate of loss, you find that we're about 40 years ahead of schedule compared to the projected loss. Can you comment on why the rate is so high and what the models are not considering, and if the models are being revised now to project into the future?
Yeah, and I apologize for the non-answer that I'm going to give you. I'm actually not a modeler, and I won't go out on a limb to speak for the modeling community. On the surface explanation is that the Arctic is known to be a very sensitive area, so the rate of the change is just by nature of that is going to be a little more variable in the rest of the globe as well. So, so I can't speak directly for the modeling community. It is increasing in many ways more quickly than the initial projections. And I wouldn't go farther than that. I think it's a great question for the modeling community. I'm confident that they will catch up to the reality or be able to explain the differences. There's a possibility this recent years is natural variability on top of climate change, and so there's always that natural component that is very important regionally as well. Thank you for your question.
Yes. Mark Dahl from the European Commission's Joint Research Centre. I was wondering, does the State of the Climate report also include spatial uncertainty estimates for the individual ECVs? I mean, do you provide any information on the spatial uncertainty of the individual products you're deriving trends for?
So for some of the trends, we do provide uncertainty bounds for the aggregated time series. So for the global and near global aggregates, we do provide some variability indicators for that. We do not, in the State of the Climate report, produce what I believe you're asking, the spatial variability. So what are the variability estimates for places on the globe? That's just doesn't fit into the State of the Climate reports. We typically report on the trend and the variability and what was seen in 2011. Many of the data sets that are included in the State of the Climate are treated much more comprehensively in other reports, data products, and monitoring products around the globe. So just because it isn't included in the State of the Climate doesn't mean it's not available. But in the State of the Climate, no, we don't provide maps of spatial estimates of variability.
Hi, Mark Doherty, European Space Agency. I have a non-technical question for you. It's a very comprehensive report that you're presenting, and I would say your presentation as well as the report is fantastic. Is there some effort made to translate this type of information into something that is digestible for the public and policymakers in the US?
So thank you for your question. We're trying very hard to do a better job of that. We provide supplemental information both by the web and with kind of a 2-pager, 8-pager approach as well, trying to distill this down and do a better job of not being not speaking in just the language of the technical language of the report. We're also, through the WMO, historically, we have had sections of the report translated into the 6 World Meteorological Organization official languages in order to reach more technical readers that read in a language other than English. But you've hit on a really important topic. It is a focus of ours. We did release some much supplemental information on climate.gov, which is the US's climate data portal for the 2011 report. And that seemed to be effective, but it's probably not effective enough. And we're trying to get better, and we're always looking for feedback and insight into how we can do a better job of that. Thank you for your question.
State your name and association, too.
Gene Tockley, Iowa State University. With regard to your analysis on the Palmer Drought Index, there's been some recent discussion about the lack of incorporation of climate variables other than temperature and precipitation. Primarily, the change in solar radiation, the decline, the global decline in near-surface wind speeds, and to some extent perhaps even humidity, rises in humidity that might affect the Palmer Drought Index. Would you care to comment on that and what effect that might have with regard to Palmer Drought, use of Palmer Drought Index moving forward?
Sure. There have actually been a lot of papers, both on the positive side, saying that in general, over large areas, the computation of Palmer is reasonable, and some saying that it needs a little bit of help. But the purpose of this particular look at this information, what we were asked to do, and if you want a little bit more information, the American Geophysical Union EOS publication, this was part of one part of blurb in that in November 20th. But basically what we were asked to do in that was to compare the drought this year with the droughts of previous years. So while it would be advantageous to incorporate humidity values and some other things which would improve the Palmer Drought Index, especially in the area of the U.S. Where the drought hit the hardest, we didn't have those data for 1934 and the 1950s necessarily, so we wanted to make sure that we did an apples-to-apples comparison.
Okay, we have time for maybe 2 more questions if we have any.
Andreas Fischlin from ETH Zurich. But along those lines, can you perhaps tell a bit more about the contribution of temperature to those previous droughts? Can you say something about that?
Yeah, if you back up, the slides aren't on there. In 1934, we had an extremely long period of drought, nearly a decade, and because of the feedbacks from the lack of precipitation, there we go. Looks like we got, if you go back one slide, please, you'll see the impact of the temperature through the most severe months of the droughts of 34, 54, and 88. And you'll see that the temperature in 34 was elevated over much of the country, and this was the result of already having been through a number of years of drought to get to this point. In the 50s, the drought was much more cyclical. It moved around the country a little more. It was fairly persistent, but not necessarily persistent for nearly a decade in every location. So the impact of the temperature was less on that. In 1988, we were basically looking at the exacerbated temperatures for the drought were mostly confined to the northern tier of the country. And you'll see even this year that the northern tier got the majority or the most severe temperature increases in their Palmer Drought Severity Index, jumping by 4, which is the difference between no drought and very, very severe drought. So just different conditions through the summers, different antecedent conditions, different parts of the El Nino, La Nina phase contributing to some of these. It just shows the variability of drought itself, and that, as I mentioned before, none of them are the same. They all have a different flavor, even if they have very similar impacts. And I hope that answered your question.
Right, one last question back in the corner.
My name is Gerd Tetzler from Germany, Disaster Reduction Committee. And I have one question on the long time series. You offered something like 180 years back in temperature area covering United States. And I was wondering about one thing. Wouldn't you have to include more uncertainty information guidance on the past, on the past records of the 19th century, for instance, because the uncertainty is not really comparable. Thank you.
Yeah, that's a great point. There were fewer observations in the late 19th century than there were in most of the 20th century. So the estimates of the temperature in the late 19th century have more variability associated with them, or more uncertainty associated with them than the recent decades. This is particularly true when looking at a map of the United States. When we look at the overall average temperature of the U.S., with the single number that represents the entire contiguous United States, we're actually using a subset of 1,218 stations that are long-term stations. So that more consistent long-term set of stations helps reduce some of that additional uncertainty in the early part of the record. It's still more uncertain in the early decades than it would be in recent decades, but those stations were chosen specifically because they go the farthest in reducing that uncertainty. So while particular locations on the map that we see today, where the trend basically has a wider band of uncertainty surrounding it, for the contiguous U.S., it is not nearly as big an issue as it is for certain parts of the contiguous U.S.
All right, and we have one
Thanks
last
a lot.
question in back.
Yeah, just. Oh, here it is. Okay. Yeah, a lot of people here have asked how they might get a copy of the report and also how they might get a copy of this presentation. So I'm not sure if you have contact information or how you'd like to advise how they might get that information.
So I think the default for this presentation, I believe we gave the most recent copy of it to Ms. Georgie, who of the U.S. State Department, who I believe is in attendance or near the meeting today. So I believe some of the staff associated with this event may be able to share a PDF of this presentation. For the copies of the State of the Climate Report itself, the URL, I won't read it. Basically, if you do a search engine result for BAMS, B-A-M-S, State of the Climate, all of the reports are online in a location at the National Climatic Data Center. So you can get all 22 of the annual reports in a PDF format. The recent years, the high-resolution versions of the entire report are very large downloads, so we've broken them up into chapters as well. But again, the best way to get to them, do a search engine for BAM's State of the Climate, find the result from NOAA.gov, and that is very likely going to get you there.
And if you have trouble getting hold of the presentation, when you get to the page for the BAM State of the Climate, there'll be a contact button. If you use that, we will make sure that you get a copy of this.
And if you talk to any of the staff here at the U.S. Center, in fact, Georgia's standing in back, we can get you a PDF if you need it. So thank you very much, Mike and Deke. Maybe we could have a round of applause for our presenters. And thank you to our audience for coming. I just want to quick remind you all, if you haven't picked one up yet, we do have programs in the back all over the place. Grab one for your friends, pass them out as much as you can. We want to spread the word about the U.S. Center. And then I also want to announce that we are raffling off a book called Our Changing Planet. It's a big, thick book. It's a volume of breathtaking images of the Earth, and we're going to be raffling it off at 5:30 for free at our presentation at the Hyperwall. So thank you all for coming.